Let's discuss one simple example about composite functions. Alright. Now here first what we'll do, say you have a function f from a to b given by f of x is equal to x plus 1, and we have g as a function from b to c given by g of x is equal to x square. And now what we have is we have set a to be 1, 2, 3, set b is 2, 3, 4. Okay, set b is 2, 3 and 4. Now I'll ask you what is set c and how we are going to define the function in this case. Alright. Now what we have is, first, see there are two ways. I'll show you both the ways. The first way is about the algebraic way where we take GOF. So I'll do one thing. My question is find both GOF and FOG. Find both of them. Okay. Now the first part is GOF. We'll do the algebraic method, which is very, very easy. Now when we do GOF, the first part. So when you do GOF, this is G of f of x, correct? G of f of x. So algebraically what do? We write G of, see, f of x. What is f of x? F of x is defined by x plus 1. So G of x plus 1. Make sense? So in terms of f of x, you're writing that. So we write G of f of x. Now the next part what we have, G of x is x square. But in place of x, what do you have? You have x plus 1, correct? So what do we get? We get this as x plus 1 whole square. So x plus 1 whole square. This is going to give us the G of f of x. Now, how do we write this in the set form? That is, see, we have 1, 2, 3. We have 2, 3, 4. Now, if you are defining set C, because G is from B to C, correct? Now, if you have to define the set C, we can write set C is equal to, so x plus 1 whole square. So 2 square, 4, then 9, then 16. This is going to be set C. Or if we are writing in terms of the ordered pair, okay, suppose if you are writing as ordered pair, then G of f of x, this is going to be, so 1 comma, so 1 is going to become 2, 2 is going to become 4. So 1 comma 4, and the next one is 2 comma 9. The next one is 3 comma 16. This is basically GOF or G of f of x. Clear with this one? Now the next part is what? FOG. That is f of g of x. So we'll do the f of g of x now. For this one, we have FOG, which is f of g of x. The first one was g of f of x, correct? Now, what is g of x? G of x is x square, correct? So we write this as f of x square, correct? Now, what did we write f of x as? F of x is nothing but, so let me write it here. F of x is nothing but x plus 1, isn't it? Now, in place of x, see here, in place of x here, we have x square. So, in place of x here, you write x square, correct? So, when you have f of x square, this is going to give us x square plus 1. So, FOG is going to give us x square plus 1. Fine. Now, we have to define the set also. Now, what do we have? First, f of g of x. But in this case, there's going to be slight difference. Because when you write g of f of x, we know what it is. because you know f of x and you know g of x, isn't it? So if you're writing it in a no in the domain form, see something like this: a, this is b, this is c. Now a to b we have function f, b to c we have function g. So a to c we have function g o f, correct? But in the second case, when we write f of g of x, now b to c, of course, we have g, isn't it? But when you're doing this one, this is f. What we need is f of g of x, isn't it? So f of g of x, we have to take it the other way around. So generally, we can't do it like this. But we can still get the function. The function is going to be x square plus 1. So this is the function fog. And what did we write? GOF. So GOF is nothing but x plus 1 whole square. This is the function. So what did we have here? 1, 2, 3. And here we had 2, 3, 4. And here we had 4, 9, 16. Correct? So GOF is from A to C and where we have the set values. Understood? This is how you calculate the composite function. Now there are certain simple basic properties. Okay, now suppose if f and g both are one-to-one functions like the one what we have right now in this example, then GOF will also be an one-to-one function, or you can say it's an injective function. All right, this is one very important part. And once we deal with invertible functions, you will understand even more like properties of it. Fine. So in the next video, we'll discuss about few problems based on composite functions.